Okay, so let's start. And hello, everyone. Good morning, good afternoon, or good evening, depends on where you are in the world. Welcome, and thank you for taking time to attend our webinar today. We are very excited to host this joint webinar for you to learn about two wonderful open source projects for big data analytics, namely Apache IoTDB and Apache SeaTunnel. Both are from the Apache Software Foundation. And about myself, my name is Pingqing Zhang. I am from TimeCo, and I am devoted to promoting the application and development and application of Apache IoTDB, which is a time series database project. I am delighted to be your host for today's webinar. Apache IoTDB is a time series database management system that integrates data collection, data storage, management, and data analysis. It was designed for resolving the pain points in IoT. For example, massive data generation, high frequency sampling, high costs of storage, low computational power of IoT devices, and so on. And Apache SeaTunnel is a very easy to use, high performance distributed data integration system, which supports real-time synchronization of massive data and is compatible with various data sources and is suitable for many complex synchronization scenarios. In today's webinar, we have invited William Guo and Haonan Hou to introduce the design and specific features of both projects. William Guo has over 20 years experience in data science. He has worked in big data teams at many famous companies like Teradata, IBM, Lenovo, and he was the former CTO of Analysis International. Besides, William is devoted to many open source projects. He is a member of the Apache Software Foundation and PMC member of Apache Dolphin Scheduler and SeaTunnel. And he is also the initiator of the Chinese community of ClickHouse. Haonan Hou also has many years experience in big data. He has worked as software engineer at National Engineering Laboratory for big data software and also at the Tsinghua University. Meanwhile, Haonan has also contributed to many open source projects, and he's PMC member of Apache IoTDB. Also, he's my colleague at TimeCo and as a senior database developer. Despite introducing William first, our topics will start with IoTDB and will be presented by Haonan firstly. If you have any questions during the talks, you could just type it in the chat and our panelists will answer it later. So now I would like to hand it over to Haonan. Haonan, would you like to share a screen?
Okay, give me some time.
Yeah. And your camera is still turned off.
Oh, yeah, sorry. Okay, so, okay. Hello, everyone. My name is Haonan Hou, and I'm an IoTDB PMC member. And welcome, and thank you for taking time to attend this webinar. Today, I'm happy here to share a talk about Apache IoTDB storage efficiency. In this talk, I'm going to introduce three continents. First, I would like to talk about IoTDB version 1.0 architecture, which is about the new distribution and standalone architecture of IoTDB. The second part is the time series data file, TS file. TS file is the IoTDB's file storage format. The third part, I would like to talk about the IoT LFM storage engine structure. which is used in IoTDB for time series data storage engine. Firstly, let me introduce the first part, the IoTDB 1.0 architecture. Firstly, I would like to introduce some rules about the IoTDB cluster. First one is the config node. Config node is it's for managing the cluster node and the partition table, and it also doing the cluster task scheduling and load balancing. The second role is the data node. Data node is for managing the time series data and the metadata, which means some schema info. And it also for query, such as the massive parallel processing, the computer engine. Please look at the picture. We have some config node for cluster manager layer. And for data layer, we have several data nodes for storage and query. And some application layers can connect to the data layer for the service. The total architecture of IoTDB version 1 is look like this. And we have some config nodes which contains the node manager, and for data partition, load balance, task schedule, and the consensus. And for data node, we have some protocols. We have session, MQTT, REST API, and JDBC to connect the client. We also have the query processing module for such as SQL parser, planner, optimizer, and the dispatcher. We have the computer engine, which supports the CQ, trigger, UTF, and some external library. In the data node, we have also a module to manage the schema info, which is called schema region. We have a different format of schema to manage, such as schema file, some metadata log, and the schema template, and some cache. And we have some data region to manage the data, which can, during the file compaction, manage the memory data, which is called mem table, and the disk data, which is called PS file, WL. We also have the consensus layer for data node, and we support several different consensus protocol, which has simple LP consensus and Redis. We also have some author module for data node, and we also support sync different data nodes data by the sync and the load module. We also support the metric module for to monitor the whole this cluster strategy. Yeah. Yes, we have also some ecosystem such as to integrate. We have support SeaTunnel, Blink, Kafka, and we also have some virtualization implications such as the Grafana, Zeppelin. And we also developed our own workbench tool for such as the PS file viewer on the IoTDB workbench. For IoTDB version 1, we have supports the following deploying mode. The first one is the lightweight standalone mode, which has extremely high performance and support the high consistency, but we don't have some highly available feature. And for the default mode, we support the extensible standalone. And it has the higher performance, higher extensibility, and supports highly available. And for cluster mode, we have a high performance cluster mode, which is recommended by our people. And we also support the strong consistency cluster mode. Okay, next I would like to introduce the lightweight standalone mode. This mode, we have a simplified consensus protocol, which means we have one config node and one data node. So we don't have some more replica. So we design this mode for simplify one replica consensus protocol for better performance. And we also have the optimized executor by changing the network transport to the local method calling. And we also optimize the cache system to reduce the redundant cache. Okay, the second part of this talk is about the time series data file format, TS file. TS file is a column-oriented file format for time series. We have some experiments to show the TS file is 85% disk space reduced compared with the InfluxDB. The total disk structure looks like this picture. We have the first part is the data part, and the second part is the index part. For the data part, we have some different level. The first one is the chunk group. Chunk group is the data of one device. And in the chunk group, we have some different chunks, which means we store the data of one environment under this device. And chunks, we have three different chunks. Means TS chunk, which store the timestamp and value together to the chunk, and time chunk is for the timestamp only, and value chunk for value only. In each chunks, we have some different page. Page also store the data of one environment on the device, and page also have three different kinds. First one, TS page means timestamp and value together, and time page for timestamp, value page for value. And we have some index structure for TS file. First one, I want to introduce the in-series index. We have three levels of statistics for this index. Well, it means pages and chunks files. The benefit is this structure can filter the data blocks, which means we can reduce the I/O and materialize the view for the query. And it also supports the aggregate function, and we can return the result directly by this statistics. And TS file also have some series index structure, which means we have some series metadata index tree. Looks like this picture, have different level. first a device, and then for the leaf node, we have the measurement, and the measurement point to the in-series index, which means time series metadata. So the benefit is we can manage a large number of time series. And for data in page, we have different encoding and compression algorithm. Look at this table. We have different for each different data type. We have some different encoding way. For both have we have both loosely and looseless encoding, and we have the compression for the second level of compression way. And LTB also supports the deadband processing algorithm STD. As you can see, if we have such 11 points in LTDB, and after we doing a flash and we use the STD, we can discard some data points, and we can only keep some important data into LTB. So LTB have some 3 levels of compression. The processing flow is as below. First, we have some optional deadband processing, which is loosely and directly discard some data points. And then we can do some encoding and to compress the data technically. And then finally, we have to do some lossless compression and then we have got some compressed data. Okay, TS file also supports loading external TS file by the SQL command. As you can see, if we have LTDB cluster, which means we have a config node and some data node, and we also want to import some external TS file. So we can use this SQL command and load this TS file folder to import this TS file to the LTDB cluster. This feature is for database upgrade and for data migrate. And it also supports auto-create schema and auto-validate schema. Okay, the third part of this talk is about the IoT-LSM storage engine structure, which is the IoTDB time series data storage engine. Okay, the total structure of the storage engine looks like this. The new insert come from the client. We have a sequence data filter to discriminate the out of orders data or sequence data into the memory first. And then after the flush, we have got some disk file. Also have the out of order space and the sequence state space. And we also have the compaction to eliminate the out of order data. The benefit of this structure is it can optimize the sequence data insert processing. It also improves the out of order data write performance. It also reduces the file compaction write amplification. Okay, let me give you an example about the total write process. Firstly, when the mem table size reaches the threshold, then the data will flash into the disk, and then we can get the test file look like this. And at the time, the LTDB will delete the WAL, write a hide loud. And then in the memory, we can record the file index, which is the test file resource to record the start time and end time of this device. Then, if we have these two new insert column, the first one, the timestamp is 2, and it's less than the end time 3. So this time, this data will go into the this auto order files. And if the timestamp is 4, it's larger than the end time 3, and they go into the sequence space, and will be a new test file. And about how to manage the memory data, we have a special structure, means array pool. When a new insert column, we will apply some needed type of array from array pool to store the data. And after the data flushed to the disk, we will return the array pool. The benefit is it can reduce the memory object initialization and GC, and it also adjusts the proportion of each data type of array in array pool automatically by the data type we inserted data. And at the end, I hope to mention that SeaTunnel support IoTDB and the data source and the destination. And the next talk will introduce more information about this. Thanks for watching. And if you have any question, you can just ask me.
Thank you, Hongnan, for the excellent presentation. Yeah, I've already noticed that there are 2 questions in the chat. Yeah, the first one is, what compression ratio can be reached when data is stored in TS file?
Okay. I have some numbers about the lossless compression. It's about 10:1, and for lossy compression, it's about 100:1.
Yeah, seems great. Okay, and the second question is, can IoTDB be deployed on the cloud?
Yes, of course. In our company Timecall, we have some solution about the Kubernetes deployments. Yes, we have some solution.
Okay. Okay, so is there any other questions? Well, okay. So if anyone has still questions, you can just type it in the chat later. And now we would like to hand it over to William and let him guide us to go deep through the SeaTunnel.
Okay. Thank you, everyone. I'd like to share some experience with IoTDB swimming with SeaTunnel. I'm William. I'm Apache Software Foundation member and also the mentor of Apache SeaTunnel. And I used to work at IBM, Teradata, Lenovo, CCC Analysis. And here is my agenda. I'd like to share some experience with IoTDB and Apache SeaTunnel. First, I will introduce what is Apache SeaTunnel, and then I will introduce you IoTDB swimming with SeaTunnel. And then I will give you example for IoTDB and SeaTunnel. Can you hear me? Anything wrong? Okay. And then And then I will tell you how to adopt IoTDB and SeaTunnel in your enterprise. So let's begin. The first part, I will tell you what is Apache SeaTunnel. I know, IoTDB is a high performance time series database, right? You can collect data from IoT devices or from Kafka into IoTDB. But how to transfer data from IoTDB to your cloud, or transfer your data to your data warehouse or data lake, or how to sync data from IoTDB to your database or other big data platform. So SeaTunnel is the tool that it just synchronize data among different data sources. Apache SeaTunnel can synchronize data from many data sources, including IoTDB, and then you can sync data into other big data platform or other database. And it has its own engine called SeaTunnel Zeta engine. And now it supports more than 100 database connectors. And in the last year, the connectors growth is more than 300%. So it's grow very fast. So, and now it got more than 4,200 stars now. And I'd like to share some cool features of Apache SeaTunnel. First is high performance synchronized engine. We have some test report that you can see that is almost more than 30 times faster than other synchronized engine. And the deployment is very simple because if you want to deploy Apache SeaTunnel, you needn't to deploy HDFS or Spark or Flink or any other third-party software. You can just deploy it with a standalone mode in one machine, or you can deploy Apache SeaTunnel with a cluster mode with more than 2 or 3 machines. It's very easy to deploy. And now it has more than 100 connectors. It can support SaaS, cloud database, cloud storage, and also other on-prem data source like Oracle, MySQL, DB2, Teradata, Greenplum, or Kafka, or FTP file, and it has more than 100 connectors. And SeaTunnel can ensure that you just synchronize data exactly once. That means it can help you to resume from the breakpoint or roll back when the whole job failed. And it has many design with a multi-checkpoint design that assures that your data will not be duplicated when the database source is something error or the sync has some errors. And SeaTunnel supports also CDC and batch mode. CDC means a change data capture. That means we can read the bin log of MySQL, Postgres, DB2, or some database, and just synchronize them to the target in real time. So for example, you can synchronize the MySQL to Kafka in real time, or synchronize data from MySQL to IoTDB. So we just support both CDC and batch mode. And of course, we support data type mapping and row or column filter and other transformers. And I will introduce in the later slide. And it's very easy to use. Here is the connectors, what we have now. And it has more than 100 connectors to help you to integrate your data to anywhere. So you can see we just support both IoTDB and InfluxDB. So that means you can just migrate from InfluxDB to IoTDB with SeaTunnel. It's very easy. And also you can synchronize data from IoTDB to your cloud with S3 file or Redshift or to Redis or to Kafka or to any destinations in your enterprise. So we can see there's so many connectors that SeaTunnel support. And here I like to introduce the Apache SeaTunnel architecture. The architecture is very simple. We have a source connector. That means we can read data and just translate to the SeaTunnel data format. And then we have the sync connector. That means we can write data to the database or data file in the data format that they know. And we have some transformers. We have filter, split, replace, UDF, SQL, something like that. It seems a little complicated. Let me show you a little example. So here is an example of a SeaTunnel. When you use SeaTunnel with IoTDB and other database, you can see it's very easy. You can just define the data source with IoTDB with URL, username, password, and you can just select data from IoTDB. And other parameter I will introduce in the later deck. And then you can use a transform to do some filter. For example, now we just add something in our SQL, and then we can sync to the other database. Now here is an example to just sync is also IoTDB, and you see there is a very simple code that is a SQL-like code to transfer data from one database to the other database. You don't care to know some complex features of Kafka or Redshift or IoTDB. You just use the SQL-like code to deploy implement the whole program. So it's very easy, you see. So now I'd like to share something that IoTDB swim with the SeaTunnel. The first, just like I just introduced to you, SeaTunnel has a source and a sync connector, and we just build the IoT source connector. And here is some features that IoT source connector in the SeaTunnel. The first function we call the batch read devices. And IoTDB is not like other database. It's something designed for the IoT devices and some measurements and something like that. So there's will be many devices in the IoTDB. And if you simply just use JDBC to synchronize data from IoTDB to MySQL, you will find that will be many tables. Because in IoTDB, I think one device just something like one table. Then if you just synchronize data from IoTDB to MySQL, you will have many tables, one table to one devices. But it's not very good for MySQL users to use, right? So SeaTunnel IoT source connector, we have a function that we can use a line by device. That means we can integrate the whole IoTDB I think data with different type with one column of device named different in different IoT records, device records, I think. I'll show you some example in later. And also we have what we call a schema projection. That's another feature. That means, when we just select something in IoTDB, you just get the measurements, but you cannot get the time or device column. And we just can synchronize data and add the hidden column with time and device. So you can very easy to use if you synchronize data from IoTDB to MySQL or to Redshift or to other database. And also we support data type mapping. And now only vector in IoTDB is not supported by the current version. And I think it will be supported in the future. And also we support we call it parallel loading. That means we can split by time and we can load the data, not only one thread, we can load the data with several threads, and it will accelerate the whole synchronization process. And also we support restore by split offset and record split offset in state. That means I support exactly once. And we just support batch mode now, but now we just didn't support the streaming mode. That means CDC mode. And I think we will support CDC mode in the future. That's the IoTDB source connector. And IoTDB sync connector, we just support other features. The first one is we just can insert not only the measurement, but also the device metadata. You can select them in the SeaTunnel row. That means we can just insert from MySQL or Kafka to IoTDB with the device metadata. And also we support timestamp and also support data type mapping and batch submit. Batch submit, that means we just, we are not like a JDBC that we just synchronize data one record by the and after the other record. We just support insert a period of time of data, and then we can just submit. And after an interval time, and then we make another submit. And also we can support retry times, and we just support exactly once. So here is what we have done with IoTDB connectors. And here is some features explanation. The first is data type mapping. That means you can map IoT data type to any data type that SeaTunnel support. Now we support Boolean and int and float, double and text in IoTDB. And when the data type transfer to the SeaTunnel data type, that means you can sync the data from IoTDB to any database that SeaTunnel supported. So that's the data type mapping. And the second one is a projection column that I just mentioned. We support a projection timestamp column in IoTDB. Here is an example. We just select from IoTDB, and actually, if what we want is just insert them to MySQL. IoTDB didn't have the timestamp, and if you have if you are using SeaTunnel, it just we can just add a field we call the timestamp, a TS column, that you can use the TS column as a timestamp in IoTDB, and just you can load the data to MySQL or S3 or Redshift with this column. And this is the projection column timestamp. And also we just support the projection column we call device name. That means you just have many devices in IoTDB, and we just can use the select align by device, and then you will find that there will be a projection column called a device name. And if you just load data from IoTDB to MySQL or to other database, that means you will have a column called a device name. And this device name just mapping to the IoTDB device. So the device column. So this is what we call projection column for device name. And also we have some other features. You can read the document online. And now I'd like to give you an example for IoTDB and SeaTunnel. And the first example is IoTDB to console. It's very easy for you to try. Now we just give you the code that we just read parallelly from IoTDB and write to the console. And now we choose just use two thread to do the SeaTunnel synchronization. And we use 24 partitions, and we just define some time step. And here is the code. You can see it's very easy. That here we will define the parallelism as 2 and the job mode batch. And we just show you the code IoTDB, the user password, and a SQL. And we just define the lower bound and upper bound, and also define the partitions. And then we will mapping this different different column in SeaTunnel. The first one is time step, TS one. We define it a big int. And the other column we call the device name. That's a projection column. We define it string. And then because this is the result from IoTDB SQL, we just temperature, we define it a float, and moisture with a big int. And then you will find that here is the IoTDB select SQL result is like this. And then when you use this SeaTunnel code, you will find there will be the result on the console like this. You see? So if the sync, you can make the sync to MySQL or to Redshift or to other things. Yeah, and this data will load to any data source you want. So this here is a very easy example from IoTDB to console. And also here is an example from MySQL to IoTDB. We just read MySQL and write to IoTDB. Now we just we just made it a batch write mode and commit when 1,000 records or 1,000 or 1 second, we will commit the whole batch at that time. And we will extract metadata like device, timestamp, and measurement. And we use the story group as a root test group. And here is the example. We just also use the parallelism 2 and job mode batch. That means we will read MySQL with 2 thread. And now here's the source. We use the JDBC and the URL for MySQL and use the driver, user, and password. And we just use a query from MySQL. And then we can sync. The sync is IoTDB. We just use the URL, the username, and the batch size, and also batch interval time, and use the story group. And now here we use the key device, use the key device name and timestamp. And the measurement fields is just a temperature and a moisture. So the MySQL result is right here. And then when we finish the SeaTunnel, we can see that the MySQL data will synchronize to IoTDB. And also you can read from InfluxDB and write to IoTDB to do the migrations. So here's an example from MySQL to IoTDB. And also, if you have several clusters of IoTDB, you can just read data from IoTDB and write to IoTDB. Here is the example. And you see it's very easy. It's just like the source. And also you can transform because the column is different. You can use some transform like just different column name here, I think. And then you use the sync connector. And then here is from one IoTDB to the other IoTDB. Now you can see the column name is different. So you can see it's very easy for you to use SeaTunnel and synchronize data from IoTDB to any database or Kafka or something, or to file or to console or to your cloud, very easy to use. And the last part I like to share with you is how to adopt IoTDB and SeaTunnel in your enterprise. Here is the whole big data architecture with IoTDB and SeaTunnel. Now, as we know, IoTDB can connect data from sensor data or from log from Kafka. And because we have a SeaTunnel connector of IoTDB, we just can read the data from IoTDB to Kafka, or from IoTDB to your edge data stream, like Doris, Dorox, or ClickHouse, or something like that. You can just do some analysis in real time. And also, SeaTunnel has a feature that we just read one data source only once, and we can write twice or more than twice. And that means you can collect data from IoTDB and to write to Kafka, and also write to your edge device and to your hoodie. And you needn't to read the IoTDB in several times. So here is what we call the streaming data. And for the batch data, you can read the data from IoTDB and just synchronize data to your Hive or to hoodie or to your Snowflake or Teradata or something like that. And then you can use some BI tools to see the result. And also, if you are using Airflow or Dolphin Scheduler, you can also to do the workflow orchestration and to use the data for the AI training or PyTorch or TensorFlow training, something like that. And also you can use the SeaTunnel connector to synchronize data from your Hive or from your database backward to your Workday or other SaaS providers, or to rational database, or to your cloud database. So somebody called it reverse ETL, but as you know, there will be many connectors that help you to connect IoTDB to any data source in your enterprise. And now is the history of Apache SeaTunnel and some roadmap. Apache SeaTunnel was founded in 2017, and we just entered the Apache Incubator in 2020 in December of 2021, and now we have the latest version is released by the last month. We just support the CDC and more than 100 connectors. And now what we are doing is to support not only the SeaTunnel Zeta engine, but also the Flink 15 and the Spark 3. And also we now are doing something that we can support a synchronized multi-table, or the whole database from one database to the other database. And what we want is to also to support, we call it the schema evolution. Schema evolution, that means when you synchronize data, if you the source table is changed, for example, there will be more columns is added, and then if we have the schema evolution feature, you needn't to change the SeaTunnel code or needn't to change the target database. We will SeaTunnel will help you to add some new column in your target database. That's called a schema evolution. And if you are do some CDC or do some batch mode, that will help you to synchronize data when the database have many data tables. So that's what we are doing. Now we have more than 4,000 stars in GitHub, and now here is some resource. You can see. Let me try. Okay, so here is our homepage, SeaTunnel.apache.org. And if you are interested, you can just go to the GitHub. You can see now we have many stars, and we have many contributors, and our project is very active. And if you are interested about that, you can. Oh, sorry. Whoa. Here. You can, if you want to learn more, you can just use Apache SeaTunnel.slack.com to add in our Slack channel. And also you can visit Twitter with AS of SeaTunnel, or on the Medium of SeaTunnel.medium.com to see some topic or some articles we just write. And if you are interested with SeaTunnel and want to talk with someone, you can just add my LinkedIn with William K 2000, and I'd like to connect with you in person. And I think here is almost the whole introduction with my topic. And thank you for everyone. Do you have some questions? So.
Thank you, William, so much for wonderful talks. You have given us a very, very insightful and very clear explanation of SeaTunnel and show us how easy to use and how powerful it is. And I noticed that there is a question which is submitted by an anonymous attendees. He or she has asked, does Apache SeaTunnel support user-defined functions?
UDF, yes, we support. As I just mentioned, we just support UDF functions. And yes, we support that. Yeah, I think where is support some UDF functions. Yeah, here.
Okay.
Yeah,
maybe this attendee has just answered that too early before you have shown this slide. Yeah.
Yep.
And let's see if there are any other questions. And I would like to share another screenshot. Yeah, here, yeah, as William has already shown, there are also some contact information of William and Haonan. It's the barcode is of the Slack workspace. You can just scan it to join the Slack workspace of both projects. And so, if there are no more questions from our attendees, we would like to thank everyone again for attending today's talk. We hope this could give you a good insight into both projects. You could visit the homepage of Apache IoTDB and SeaTunnel for more details, and also you can just write an email or connect to our to the two panelists of ours by LinkedIn or follow us on Twitter. And after the webinar, you will be automatically redirected to a survey regarding the IoTDB and SeaTunnel, which is completely voluntary and anonymous. You could leave us your email address if you are interested, or if you want to attend more of our events in the future. Otherwise, we won't get any personal information of yours. So I think, yeah, I didn't see any further questions, and I think we are done with today's webinar. And so I'd like to thank all of you again, and thank our panelists, thank William, thank Haonan for the sharing and the presentation today.
Thank you all.
Thank you.
Okay,
Thank
so
you.
wish everyone a nice day, and see you next time.
See you. Bye-bye.
Bye.
See you.